Hi, my name is Anas Mazioudi. I'm a software engineer for 10 plus years now. I'm passionate about software design and architecture. And you can find me on the usual social networks under the username Disclosure. I also have a personal blog, disclosure.com, where I talk about or write about topics I'm interested in. Um, the slides of this presentation are going to be available there. So I encourage you to go and check it out. So today I am going to talk about API security and design and architecture. And the reason I chose to talk about that is that usually uh, people attribute security issues to software bugs, human mistakes, misconfigurations, and things like that. But the matter of fact is that sometimes security issues can stem from poor architecture and bad design. And so, in this talk, I wanted to share with you some examples of design decisions that we software developers and architects can make when building software, and discuss the security implications of those decisions. This picture right here is the Tacoma Narrows Bridge in the U.S. Was built in 1940, and just a few months later, it collapsed. There was one casualty, which was a dog that unfortunately could not escape the collapse. Could have been worse. Um, and the collapse was actually attributed to poor architecture of the bridge. So during this presentation, I'm going to take as an example a classic eShop website where people can browse the catalog and order some items and buy them. We're also going to suppose that for this eShop website that we have already done the domain analysis using strategic domain-driven design, that we have already identified the different domains and subdomains we have, how they interact with each other. They have defined clear boundaries between them and defined all the entities and aggregate routes and so on. And we're going to talk about three main design decisions and discuss their implication on security. First one is the general architecture of our eShop website. The second point is going to be about session management, and the third point about input validation. Now, when starting to build a software, an eShop website like this, one of the first and most important decisions that we need to take is to whether to go with microservices or not. After all, microservices are an interesting take, an interesting and modern take on software architecture. And the idea is that instead of having one big block of your software, you will split it into multiple small, independent, and super focused services that can interact with each other in interesting ways to provide a business value. And the interesting part in the microservices architecture is that uh, the fact that each service is independent from the other means that they can be managed by different teams. They can have different technical stacks. They can have their own database, their own infrastructure. So this introduces loose coupling at the organization level, but also at the infrastructure level, and it gives you more flexibility when building and managing the software overall. You also get the benefit of being able to scale each microservice depending on their individual need, which is a really interesting property to have in your system. Now, on the other end of the spectrum, you've got your classical monolith architecture, which is a typical n-tier architecture where we have your business layer and infrastructure layer and database. Um, the monolith is usually shipped as one deployment unit, and they have this bad reputation because the business layer tends to get overly complex over time as we're adding more features to the software, and things start to get more tightly coupled and intertwined together, and you end up with a spaghetti code, as we say, or the big ball of mud. Now, the way I presented these two styles of architecture, it may seem that microservices are superior in every way, but the matter of fact is that it's not, because microservices come with a cost, a huge cost actually. The first one is infrastructure complexity, because now each microservice is going to own its own stack, its own database, it needs dedicated servers, it needs its own repository. So it it adds it adds complexity to your infrastructure. Now you have more servers to maintain, more databases to configure, and more things to secure. You also have the operational overhead, because you need more people, because you have more resources to manage, more networks to manage, more interaction and combinations between the different services you have in your system. So that is also an added cost that needs to be managed. You also have performance considerations or issues, because while in a monolith, the different uh, modules interact with each other using simple function call in the same process. Now, with microservices, the interaction happens over the network. And we all know that network is unreliable and it will fail. It will eventually fail. And so you need to design your system for failure, and you need to make it resilient and make sure that even when the network is having issues, that your system continues to behave in a good way, which is also an extra cost to take into consideration. Not talking about, not going to talk a lot about the eventual consistency issue, because now you have, if you need to have consistency in your system, now your transactional boundaries span multiple services. And so since we can't do distributed transactions because that's a bad thing, you'll have to settle for eventual consistency, which for some use cases it might be a really fine solution. So the main idea here is that microservices introduce a lot of complexity, and we all know that complexity is the enemy of security. And so the more complex your system is, the harder it is to secure. And this is why microservices can actually impact negatively your infrastructure and your security. Now, if we can't do microservices, what are the alternatives? Well, it turns out there is something called the modular monolith, which is just a fancy way of doing monolith way, in applying good old software design principles. So in your business layer, instead of having tightly coupled modules, you will have independent modules that have clear boundaries between them. You can achieve loose coupling by making communication between these modules go through a message bus. It could be an in-memory message bus, or it could be an external, independent message bus like a RabbitMQ. Uh, but you still have the benefit of, the simplicity of a monolith, which is one single repository, one deployment unit, one thing to configure, and one thing to secure and care about. I put a link to a GitHub repository by a user that has an unpronounceable username, so I'm not going to try to pronounce that. But this is an interesting repository that has a real world use case of implementing modular monolith with DDD in a business domain of managing meetings. So I encourage you to go check that repository. It has an extensive documentation over the decisions of how it is architecture and how things are separated, how communication and how loose coupling is achieved. And it has really interesting content in there. So I encourage you to check that out. So the modular monolith is what I'm advocating for here, but you don't have to take my word for it. I have some, real world case studies to back up my claim. So Doctolib is a major French SaaS provider. They provide, an online service that allows people to book appointments with their doctors. They operate on three major European countries: France, Italy, and Germany. They have two big web apps, one for individuals so that they can book appointments with their doctors, and the other one for health professionals to manage their bookings and their agenda and their patients. So Doctolib has over 300 developers. They do continuous delivery with a pace of 3 releases per day. And during COVID, they actually achieved or arrived at a peak activity of 10 million requests per minute on July 12th, 2021. All this required over 2,500 servers in order to, absorb this activity at peak times. And the interesting point here is that all of this was done using a monolith, a monorepository. All the code is in one single repository. There is one single deployment unit, one application to deploy over all the 2,500 servers, and they have a single Postgres database. Now, Doctolib is really an extreme example of how a monolith architecture can get you really, really far. And they are maybe pushing the, or approaching the limit of what is physically possible to do with a monolith at scale. But it is an interesting uh, case to study, and it actually proves that monoliths are not, really as bad as we think, and that they can really uh, achieve interesting results at scale. Another case study for Amazon Prime Videos, which is a popular video streaming service. They have posted in their blog earlier this year an article where they claim that they have achieved a cost reduction of over of 90% by moving from a distributed microservice architecture to a monolith one. So just two examples of real world cases where modular monoliths or monoliths are actually better suited for the system than microservices, because of course they are simpler to reason about, and they are simpler to manage, and so also are more secure. So main takeaway: microservices create more problems than they solve, and monolith, when done right, can go really a long way. Now, going forward, the next point is going to be about session management. Now, session management is the idea of that we don't want to annoy the user and ask it for their credentials each time they interact with our API. So we're going to only ask for their credentials once, and then we validate them, and then we create a session object that represents the fact that this user is authorized to access the application because we have already validated their credentials. Of course, this does not apply for server-to-server API calls. This is only the case of a human user interacting with a web application. So there are two major ways of doing session management. The first one, which is the modern take of session management, is using Json Web Tokens, or JWTs. So JWTs is a specification on how to securely store and exchange session data between different parties in JSON format. So the specification says that you can, define this object in this way. It has three main parts: a header, a payload, and a footer, which has a signature, a cryptographic signature, that to check that the JWT has not been tampered with, and that it is actually valid and was issued by the authority we trust. And inside the payload, we can hold arbitrary data, where we usually put our session information. It could be, username, email, maybe some roles the user have. And the main advantage of JWTs is that they save database round trips, because Each time the user interacts with the server, they actually send the JSON Web Token, and we everything that is needed to validate the JSON Web Token is already inside it. So we don't have to, go and access data in the database in order to verify the authenticity of the JSON Web Token. And that gives you an advantage at scale because you're saving up some database round trips, which is uh, always helpful. Now, the other way of doing session management, or the traditional way, is using session cookies. Session cookies, are a really simple concept to understand. They work out of the box because most of the major web framework already support cookies, know how to deal with them, but also the browsers that the user are using already know how to deal with cookies. So they know that they need to be sent automatically for each request. So it's not your responsibility as a developer to do that. The browser will do it for you. And so it has less things and less responsibility for you and less chances to do things wrong, which is a really good advantage in terms of security. Of course, session data is stored on the backend. So each time the user interacts with the web application, they send the session cookies, which is generally just a session ID stored in the cookie. And then you use that ID and to retrieve the session object in your it could be in your database or in cache, and then you have access to the user information and can allow the user to access the web application. Now the question is which one to use. Now cookies have the advantage of a simple design. They have really nothing inherently insecure about them or bad. So when used correctly, they are a really good way of doing session management. JWTs, on the other hand, they're easy to make mistakes with when validating them manually. They require really good understanding of cryptography and reading the specification and knowing what each field actually mean and how they should be used, how to validate them correctly. They also have the problem of the data inside them that could go stale, and so a user might end up being unauthorized, but because of some data changes that happens on the database, but the JSON Web Token is still valid. So anyone that has hold of the chart can still access the system, even though the configuration says it should not. And so in order to circumvent that, you need to implement token revocations. And that is, a lot of, another responsibility to have. And also, it gives you more chances to get things wrong. And it also defeats the purpose of the JWT in the first place, because one of their advantages is to, save database round trips. Now, if you're going to maintain a list of revoked tokens and check it for each time a user interacts with your web app, we're still doing database round trips for each call. This is a screenshot of the OWASP API top 10 of this year, broken authentication section. And you can see that three of the items on the list talk about JWTs because they're usually, hard to get right, especially when it comes to validating JSON Web Tokens. So it's a source of a security issue. And cookies are a simpler alternative. So that's what I'm advocating for. You don't really need to use JWTs. Session cookies could be really, enough for your needs. And that's the second takeaway. Don't dismiss using cookie-based session management. They are still relevant and provide simplicity and great security. Now, third point is about input validation. Input validation ensures that the data sent by clients adheres to the defined constraints of our applications. It is an important security measure, and if you don't have validation, you have zero security in your app. So that's not something to skip doing in your next project. And the interesting thing about input validation is that it can and actually should be implemented at different levels, usually in the front and the back end. So the client side validation, which is the front part, uh, can be seen as a convenience for users because it doesn't really serve a security purpose, but actually helps the user, you know, and saves time for the users and the servers because if the client knows that a request is invalid and it's not going to succeed on the server side, then it's not worth sending it in the first place. So we just, you know, uh, inform the user that the request is invalid and invite them to correct the request before sending it. And so that's good for everyone. But they have this other interesting side effect, I would say, because if you implemented your client-side validation properly, this means that not you should not have any invalid requests arriving in your backend because they would already be filtered by the client side. And so this means that if you ever see in your monitoring tools that you receive invalid requests in your API or backend, that means one of two things. First thing, you probably have a corner case or a validation case that you have missed in your client side, in which case you just add it and fix it, and you will stop seeing that error uh, on your backend. Second thing, which is related to security and it's an interesting property, is that it can be a signal that someone is actually tinkering with your API and trying to experiment and force some requests. And that is actually a good signal to have. It means usually that things are a little bit fishy, and you need to, take that into consideration and maybe act accordingly. Server-side validation is actually the most important part of input validation. It is a crucial security measure to prevent API misuse, like injection attacks and data corruptions and etc. Uh, it also have this convenience property, which because each time you fail a validation on the backend side, you usually send back or report back to the caller why the validation failed so that they can fix their requests. They're usually implemented at the controller level, and this kind of validation is mainly going to validate the shape and the types of the received data. So here is an example taken from our eShop website. We have a basket item, which is had three different properties: a product ID, product name, and a quantity. If we have a business rule that says that the quantity should never be negative, for example, and that the product ID should be an integer, the product name should not be empty. So those business rules are going to be implemented as validation rules. This is what you see in the bottom part in the validator, and you express the shape and the type of the data that you accept in your API, and everything that does not respect those constraints is going to be rejected. So the main point of this part is this: server-side validation, as I've mentioned in the previous slide, should not be a substitute for domain validation. So what is domain validation? Domain validation is actually the validation that you have at the business layer. It implements the business rules and enforces the domain invariants. The quantity that should always be superior to one is a business rule, and so it needs to be present in the business layer as a validation uh, rule. And so it also gives you the advantage of being able to test your business rules by only testing your domain layer, which is way easier to do than testing at the controller level or at the client side level. So this is an example of the same rule about the quantity, but implemented at the domain layer. So before creating the domain entity, the basket item, in the constructor, we check for if the business roles and the invariants are violated or not. In this case, if the quantity is less than one, then we're going to throw an exception because the business rule is violated. Now, note here that I'm actually throwing an exception and not just returning a problem object. And that's the interesting idea here is that when validation fails at the domain layer, it is an exceptional case. And so it should be considered as an error. If something fails at the domain layer, it is an error and you should log it and monitor it and make sure it does not happen. Because everything that arrives to the domain layer should be valid. You should expect it to be valid. And if it's not valid, that's an exceptional case. However, for the controller level server-side validation, it is actually normal to receive invalid requests because people can make mistakes, and it's the responsibility of this layer to filter out all those normal cases. So if something passes the controller validation, it should also pass the domain validation. And if it's not the case, that should be considered as an error. Now, in terms of security, this actually means that the domain validation is a fortification line or a second line of defense. Instead, the first validation layer fails. And that's actually an interesting property to have in your system to make it more robust and secure. And so, third takeaway is that you should implement proper validation on both client and server side, and that you should use your domain model and implement and enforce the business invariants and fail when incorrect commands are detected. So, wrapping up, first takeaway is to resist the temptation to use microservices unless it's really justified, because otherwise you're just adding complexity and adding costs and impacting the security, weakening the security of our system without, having the advantages of microservices. Second point is that you can actually use session-based cookies for session management in your APIs instead of JWTs. They are perfectly valid, way to manage sessions. And if you ever go with JWTs, make sure you are taking into consideration the security implications of, stale JWTs or revoked Json Web Tokens. Third point is to implement proper validation at the client and the server side, and not forgetting to implement the business rules and the invariants in your domain layer. So that was all. I hope you enjoyed this talk, and thank you.